Let's talk about theoretical yields, actual yields, and percentage yields. So when a chemical reaction happens, it will produce or yield something. For instance, in this basic example, we can see that hydrogen reacts with oxygen to produce or yield H2O, or water. So let's take a look at the definitions. The theoretical yield is the maximum amount that you can produce in a chemical reaction. This rarely ever happens. The only way this happens is if everything goes perfect in a chemical reaction, which is very uncommon. The actual yield is the amount you actually produce in a chemical reaction. And the percent yield is the percentage of the theoretical yield that was actually produced. So for instance, if the theoretical yield is 10 grams and you actually produce 5 grams, well, that would be a 50% yield. You produced 50% of what you theoretically could have. So let's look at a practice problem. For the balanced equation below, if the reaction of 40.8 grams of this compound, C6H6O3, produces a 39% yield, how many grams of H2O would be produced? Well, let's start by trying to find the theoretical yield. So we do that by taking our given, which is 40.8 grams of this compound, 40.8 grams C6H6O3, and we want to try to convert this, and our final value should be in grams of H2O, because that's the product. So the first thing to do here is to convert this from grams of this compound to moles of this compound. And if you calculate the molar mass of C6H6O3, you should come up with 126.111 grams. Now you're going to have to convert, you're going to have to do a mole to mole conversion. So we're trying to find H2O, and we're starting with this compound here. This compound, there's 3 times as many moles of H2O, as you can see by the 3 here, as there's only 1 mole for this compound. So let's put 1 mole C6H6O3 down here, and 3 moles of H2O up here. Then we're going to have to convert moles of H2O to grams of H2O. And we'll see if I have enough space here to do it. If not, I'll bring it down here. But anyway, if you calculate the molar mass of H2O, you should come up with 18.015 grams of H2O. And that's in 1 mole of H2O. So this will leave your final answer in grams of H2O, because this will cancel out, this will cancel out, and this will cancel out. So we're going to be left with grams of H2O once we plug all of this into our calculator. So 40.8 divided by 126.111 times 3 times 18.015 should get you 17.48 grams of H2O. Now, that's your theoretical yield. But in this equation, we only had a 39% actual yield. So, what's 39% of 17.48? Well, you can just multiply this number by 0.39. That'll tell you what 39% of that number is. And if you enter that in your calculator, you should come up with 6.819 grams of H2O. That is our actual yield. We produce 39% of this theoretical yield, and 39% of that is 6.819 grams of H2O. That's how much was produced in this reaction. Let's look at another problem. For the balanced equation below, if the reaction of 91.3 grams of C3H6 produces a 81.3% yield, how many grams of CO2 would be produced? Well, once again, let's start by calculating what the theoretical yield is. And we're going to do that by taking our given of 91.3 grams of C3H6, and the first thing to do is convert it into moles. 1 mole of C3H6. If you calculate the molar mass of that compound, you should come up with 42.081 grams. Now we have to do our mole to mole conversion. So let's look at the ratio of moles between the compound that we're given and the one that our final answer has to be, which is CO2. So we have 2 C3H6 and 6 CO2. So CO2 is what we're trying to find, so we put that on top. We're going to say 6 mole of CO2 over 2 mole of C3H6. And you can probably notice right away we can simplify this from 6 over 2 to 3 over 1. Now we need our final answer to be in grams of CO2. So let's simplify this, or let's add another step to this where we're going to find the molar mass of CO2. And if you calculate that, you should come up with 44.009 grams. So you can just plug all this into your calculator. 91.3 divided by 42.081 times 3 times 44.009, and that should give you 286.449 grams of CO2. That's what we'll be left with, because this will cancel out, this will cancel out, this will cancel out, leaving our final answer in grams of CO2. So this is the theoretical yield, but the actual yield is 81.3. So to find out what 81.3% of this number is, we have to once again multiply it, and this time it's going to be by 0.813. And that should give you 232.883 grams of CO2. That's the actual yield that was produced in this reaction. That's how much CO2 was produced. 232.883 grams. Any questions? Comment below.